Memari again with another experiment. This experiment is about determining functional group of unknown samples. To determine the functional group, there are different ways that you could approach. You can do spectroscopy technique, and based on the location of the peak, especially like for IR spectroscopy, you would determine the functional group. But in the organic lab, we are not going to depend only on the IR because not every lab has the IR machine. So we are going to determine the functional group using solubility test and classification test. Based on the solubility, when you look at when you read the experiment from the lab manual, and I also want you to please watch the video for pre-lab discussion for this experiment, you would see the tables that would tell you which functional group would be soluble in which of the. So in general, we are going to start with the solubility test first. In general, if an organic compound dissolves in water, it must be highly polar. And those are the compounds that they are polar compound with a limited number of carbons. So if you have alcohol with 4 carbon or less than 5 carbon, it would dissolve in water. Ketone, aldehyde, carboxylic acid, esters, amines, if they have up to 4 carbon, they would dissolve in water. If the compound does not dissolve in water, it doesn't mean that it's not polar. It could be polar, but it contains more carbon in the carbon chain, which the non-polar part of the molecule takes the priority or takes it over. So it's the non-polar part is more significant, and is, as a result, is not going to dissolve in water. So the pattern or the trend, the steps that we are testing the solubility. First, we test solubility in water, then solubility in hydrochloric acid. In a 5% hydrochloric acid, the only compound that would dissolve is going to be a basic compound. And we just want to make sure that you do not test solubility in HCl for the compounds that they are already water soluble, because like HCl is 95% water. If the compound dissolves in water, definitely would dissolve in HCl. So we have no conclusion for the functional group. It could be ketone that with 3 carbon, like propanone, and it would dissolve in water. At the same time, it would dissolve in HCl. So it's not going to give information. So first we test solubility in water, then HCl. If it doesn't dissolve in water, it doesn't dissolve in HCl, then we test for sodium hydroxide, which I'm going to explain that one step at a time. But first, we are going to determine the solubility of the unknowns that we have in water. Based on the procedure, we are going to take a test tube. I pre-labeled these test tubes. I already know that I have 6 test tubes because I have 6 unknown samples. My unknown starts with unknown 1, 2, 3, which is a solid compound, 4, 5, and 6. If it's a liquid, we put like 3 drops of the unknown liquid in a test tube, and we add 3 milliliters of water. So I'm going to add the sample, the unknowns first into the test tubes. I'm going to add 3 drops, 1, 2, and 3 drops of the unknown 1. Unknown 2, going to add 3 drops of unknown 2 into test tube 2, and so on. I have unknown 4, which is right here. 3 drops of unknown 4. These are the liquid unknowns. And unknown 6 is liquid. Okay. Unknown 3 and unknown 5, these unknowns are solid. So for the solid, based on the procedure, we are adding about 0.1 grams. That ratio has to stay proper. If you use too much of the solid, even if the compound is soluble in the solvent, it will get saturated and there would be leftover of the solid and you won't be able to detect if it's soluble or not. Then for liquid unknowns, if you put too much of the unknown and with a limited amount of the solvent, if it gets saturated, partially would dissolve and then the leftover would stay and form the second layer and you don't know if the compound is soluble or not. So we are going to use about 0.1 gram of the sample. I just want to show you something because sometimes in the lab, I tell the student use tip of a spatula of the solid unknown, use just 3 drops or 3 to 4 drops of the liquid unknown. The tip of a spatula, what is considered as like tip of a spatula? The whole spatula is not the spatula from like here to the end. Same thing that if you have a spoon, the stem of the spoon, you don't get food in there, you just get the spoon of the food. So halfway would be half a spatula. Like tip of the spatula would be like less than 1/3. And it depends on the sample. Sometimes sample is like the unknown or the compound is flaky, so it might take more volume. Other times if it's compact, it takes less volume. But this is like a tip of a spatula, what I mean for this unknown. So I'm going to show you that this is about 0.1. So this is the amount, tip of the spatula for this unknown 3. So for the next solubility test, I'm just going to take about this much of the sample. So it would be just the tip of a spatula. And okay, if I take that tip of a spatula is like 0.08. And that should be good enough for the solubility test. Just want to show you how much is going to be if we put 1 down. It's a very small amount because I don't want to saturate the mixture. So 0.096, about 0.1, and I would transfer that into the test tube. So I can use, every time I'm using unknown number 3 for the solubility, I could use that much just using a spatula, tip of a spatula of the sample. So for other solubilities, I'm not measuring that. Is a qualitative analysis, it's not quantitative, and that's the reason that I approximate about tip of spatula. So for unknown 5, also is solid compound, I'm going to use spatula. And I use tip of spatula. Just a few crystals of the sample for this unknown. But again, tip of a spatula, which means like about less than half, about 1/3 of the spatula. So don't put like full spatula of the sample. Next, this approximation. Next, in the manual, I even say 3 milliliters of water or 3 full droppers. I want to show you when I say 3 full dropper, what does it mean? This is going to save time. So I don't mind students, time to be saved. I want to show you if we have like a full dropper, it's about 1 milliliter, and that approximation is valid. So in order to get full dropper of the liquid, I'm going to squeeze the dropper rubber ball, release it while it's in the liquid, and maximum amount of the water that can get in, and I transfer to the graduate cylinder. 1, 2, and 3. There is no reason for me to measure with the dropper, transfer to graduate cylinder. I could have just transferred to the graduate cylinder. But this is the reason I do this, to show you that if I get 3 full dropper, this is about 3 milliliters of the sample. If you could see that 3 milliliters, is qualitative analysis. Again, it's not quantitative, and we are using graduate cylinder, but it's about 3 milliliters. So for the rest of the test tube, so for the first test tube, I'm adding 3 milliliters of the water using graduate cylinder. Now, to get 3 milliliters to the second graduate cylinder, I have 2 ways to do it, just showing different shortcuts. If the test tubes are the same size of test tubes, I could hold one test tube against the other one and add enough liquid, enough solvent to make the same level, okay? To make it same level. So that is 3 milliliters, well, exact same as the other one, same level. Or I could just take the test tube and I say, well, I can use 3 full dropper. 1, 2, and 3 full dropper. Now, is this compound, let me finish it all and then I will show you if it's soluble or not. Add the 3 milliliters to each of the test tubes. Okay, going to start with the unknown 1 in water. Unknown 1 in water, it might look the 1 layer, but when you mix it, see this droplets of oil is coming down into the liquid and going up, and I can add more drops to make the level or the layer thicker for you to see. This is for the video purpose. If you were in the lab, you didn't have to do this. There's 1 layer of the unknown, and then this is the water. So we have the 2 layers. If 2 layers form, that means the compound is not soluble in this solvent. So unknown 1 is not soluble in water. So you're just actually just watching the video and recording the observation. So unknown 1 is not soluble in water. The reason, because second layer form, or when I shake it like this, droplets of the oil, it goes into the water and it comes back up. Unknown 2, okay, you could probably see this also because it's a little bit more colorful than that one. The oil down and moving up. See that it's kind of cloudy, and the oil comes down, goes back up. Now, unknown 3 is a solid compound. This one is easier because you can see that the solid did not dissolve. So also this one is not soluble in water. So I hope you could see better with the black background. So no pictures needed for this one. That's unknown 3, not soluble. Unknown 4 is liquid, very similar to unknown 2 because it's cloudy, and it turns, because it's cloudy and the droplets of oil coming down and going up, that's not soluble either. If it was soluble, you would have seen it like the bottom portion of this, just very clear liquid, if it was soluble. So that was unknown 4, not soluble. Unknown 5 is a solid compound, not soluble, it did not dissolve, and we're going to show it with the black background. Not, it's visible that it did not dissolve, none of it dissolved. So 5 did not dissolve. And unknown 6 also, it shows very oily. It shows very oily right here. So it's not soluble. So none of the unknowns actually dissolved in water. Okay. Because the picture was not very clear and the video was hard to see, I added few extra drop of the unknown 4, and I add food coloring so you could see it better, like 2 layers that are formed. And even if I mix it, after I wait for like 10-15 seconds, it separates. That's for unknown number 1. The same thing happened. Second layer is formed, the clear layer is formed, and unknown number 2, 2 layers are formed. And unknown number 6, this was the solubility in water. I kind of went backward, and I thought adding the food coloring to water, it might show the layers better.